Hello to all of you. This is Dr. Dhaval Maheta, and today we will understand how to split the data while running the neural network in Rapidminer. Kindly refer my previous video of this series where you will find the theoretical aspects of neural network. Let me remove this and have a fresh start from here. I'll bring the data set R1. I'll connect this with a spline. I'll press this play button. And you can see here there is a age, gender, chest pain type, resting blood pressure, cholesterol, fasting BS, resting ES, ECG, max HR exercise, old peak, and ST slope, and a patient is having a heart disease or not. Basically, it's a classification problem. So I'll again come in the design, and this time I will activate select attribute operator from here. I'll drag it and drop it here. I'll go in subsetting, select the attributes. Now I'll select those attributes which are from which I want to create the model. So these are age, cholesterol, fasting BS, heart disease, old peak, resting blood pressure. Now I'll set the role of it. Basically, neural network falls in the category of supervised learning technique in which we have to define the target variable, also known as a dependent variable. So I'll drop the set role here. I'll go in, enter the value. I'll activate the heart disease. Make it sure that your target role is labeled. Then only you will be able to run the analysis. After this is done, you will have to activate the operator, which is split data operator. You will have to drag it and drop it here, split data. So this operator basically will divide the data into some proportions, which we will specify. So activate split data, go in edit enumerations, add the entry 0.7, add the entry 0.3. So we are dividing the data set into 70% training and 30% testing data set. Now activate the neural network algorithm. Drag it and drop it here. So the 70% data is going into training. Disconnect this line. And remaining 30% will be going for the testing. So apply the model. We'll bring the model here. Now I will connect this line model with the model, and the testing data set will be passed through this operator. Now I will activate the performance from here. Performance which is based on classification. Why? Because it is a classification problem. I'll connect label with labeled, performance with the result window, and model with the result. Now I'll press the play button from here. You got the output. You have to go in the performance vector. Now you can see here that the algorithm has classified 98 cases correctly and 113 cases correctly. How it is, let us see. See, in actually, a person was having the heart disease. A person was not having a heart disease, and the algorithm also predicted that the person is not having the heart disease. So 98 cases correctly classified. Here, a person was having a heart disease, and the algorithm also predicted that yes, the person should have a heart disease based on the attributes which are given. So 98 plus 130 are correctly classified cases, and therefore the accuracy which we have achieved is 76.73%. The misclassification has happened here. The person was having a heart disease, but algorithm predicted no, the person is not having a heart disease. Here, similarly, you can see that the person does not have a heart disease, but the algorithm is predicting that a person is having the heart disease. So this is a misclassification which has happened. Now, Uh, you can increase the accuracy by increasing the layers in your neural net. So how you can do this? You can go in neural net and you can add more and more layers here. At present, let us see how many layers are there. Let us run it. So you are having only one hidden layer with 6 nodes. I'll again go in design. I'll activate neural net, edit the list, and I'll say that include the first hidden layer 1, and therefore there should be 5 layer sizes. Add the entry. Hidden layer 2, include 5 entries. Apply. Run the model. Now you can see it is having hidden 1 and hidden 2. Is performance vector increased? Is accuracy increased? So now it has increased by 7, it is now 73.82%. Now here you have to see that the output is, there are 2 outputs. No need to worry. It is basically because we are having a heart disease classification problem where yes and no is used, and therefore we are having 2 outputs. The call, that how many hidden layers should be there, how many nodes should be there, it is upon the researcher. Moreover, increasing more and more layers will increase the time for running the algorithm. Now, what do I mean to say about this uh, learning rate? So, a learning rate is a tuning parameter in an optimization algorithm that determines the step size at each iteration while moving towards a minimum of a loss function. The momentum is an extension to the gradient descent optimization algorithm that allows the search to build inertia in a direction in the search space. Now, what do I mean to say? Say, for example, if I increase the momentum and I make it 1.1, so the speed of correction of the losses will increase. See, you can see the output. I again go back, and now I change this output to zero point 0.5, and now I'll run it. You can see it gives me where my synaptic weights are maximum. So if I increase this and make it to 1.5, I'll be able to identify which are the most significant synaptic weights, 1 and 2. So keep it 0.9 as a default. You can also increase or decrease the learning rate if you want from here. Press the play button. This thing also can be done. But basically, you'll have to remember that how many layers have to be done, have to be considered, will depend upon the researcher as well as the time taken to run this algorithm. So here, if you, by increasing the layers, if your accuracy is increasing, you can increase the layers. For more videos on neural network and Rapidminer, kindly subscribe to my channel. Please refer my playlist in which I have already uploaded many videos of Rapidminer. You can follow me on LinkedIn and Twitter. Don't forget to press the like button.